नमस्कार साथियों, स्वागत है आप सभी का मेरे YouTube चैनल पर। साथियों, आज इस वीडियो में हम स्टेबिलिटी का चैप्टर 4 स्टार्ट करने जा रहे हैं, जो कि है सम इम्पॉर्टेंट टर्म्स। तो चलिए बिना किसी देरी के शुरू करते हैं। साथियों, सबसे पहले आती है कुछ डेफिनेशंस जो यह बताती है कि डिस्प्लेसमेंट, लाइट डिस्प्लेसमेंट, लोड डिस्प्लेसमेंट, प्रेजेंट डिस्प्लेसमेंट, डेड वेट अबोर्ड, डेड वेट अवेलेबल, वाटर प्लेन कोफिशिएंट, ब्लॉक कोफिशिएंट, रिजर्व बॉयंसी और टीपीसी यानी कि टन्स पर सेंटीमीटर क्या होते हैं। चलिए एक एक करके सबको समझते हैं। डिस्प्लेसमेंट, द टर्म डिस्प्लेसमेंट कॉमनली यूज्ड टू डिनोट द मास ऑफ शिप इन टन्स। सेकेंड, लाइट डिस्प्लेसमेंट सेज दैट द मास ऑफ द एम्प्टी शिप विदाउट any cargo, fuel, lubricating oil, ballast water, fresh and feed water in tanks, consumable stores or passengers and crew and their effect. Load displacement says that the total mass of the ship when she is floating in salt water with her summer load line at the water surface. Fourth, present displacement says that the mass of the ship at present, it is the sum of light displacement of the ship and everything on board at present. Fifth, deadweight says that the total mass of cargo, fuel, fresh water, etc. that a ship can carry when she is floating in salt water with her summer load line at the water surface. And its formula is load displacement minus light displacement. Deadweight abroad says that the total mass of cargo, fuel, ballast, fresh water, etc. on board at present, and its formula is present displacement minus light displacement. Deadweight available says that the total mass of cargo, fuel, fresh water, etc. that can be put on the ship at present to bring her summer load line to the water surface in salt water, and its formula is load displacement minus present displacement. Water plane coefficient says that water plane coefficient or coefficient of fineness of water plane area is the ratio of area of the water plane to the area of rectangle having the same length and maximum breadth. Its formula is area of water plane divided by length into breadth. Ninth, block coefficient के definition says that block coefficient or coefficient of fineness of displacement at any draft is the ratio of the underwater volume of the ship at that draft to a rectangular box having the same extreme dimensions. Its formula is underwater volume divided by length into breadth into draft. 10th, रिजर्व buoyancy की डेफिनेशन कहती है कि द वॉल्यूम ऑफ द एनक्लोज स्पेस अबव द वाटर इट लाइन में बी एक्सप्रेस्ड एज अ वॉल्यूम इन मीटर क्यूब और एज अ परसेंटेज ऑफ द टोटल वॉल्यूम ऑफ शिप. इट्स फॉर्मूला इज टोटल वॉल्यूम माइनस अंडर वाटर वॉल्यूम, एंड इफ यू वांट टू फाइंड परसेंटेज देन अबव वाटर वॉल्यूम डिवाइडेड बाय टोटल वॉल्यूम मल्टीप्लाई बाय 100. 11th, टीपीसी और टन्स पर सेंटीमीटर की डेफिनेशन कहती है कि टीपीसी इज द नंबर ऑफ टन्स रिक्वायर्ड टू कॉज द शिप टू सिंक और राइज बाय 1 सेंटीमीटर. टीपीसी इज इंडिकेटेड एज टन्स पर सेंटीमीटर इनवर्स. इट्स फॉर्मूला इज एरिया डिवाइडेड बाय 100 मल्टीप्लाई बाय डेंसिटी ऑफ वाटर डिस्प्लेस. तो साथियों, यह थे कुछ इंपॉर्टेंट टर्म्स अबाउट शिप स्टेबिलिटी. चलिए अब बढ़ते हैं न्यूमेरिकल की तरफ. तो इसमें कुल 10 न्यूमेरिकल है. यह पार्ट 1 है, तो 5 न्यूमेरिकल इसमें करते हैं, बाकी पार्ट 2 में करेंगे. सो विदाउट वेस्टिंग टाइम लेट्स गेट स्टार्टेड. So let's start the numericals. And first question says that a box-shaped vessel 120 meter long, 15 meter wide has light draft of 4 meter and load draft of 9.8 meter in salt water. Find light displacement, load displacement and dead weight. So we have to find light displacement, load displacement and dead weight. For that we will find the individual terms for light displacement, load displacement and dead weight. So let's start the first question. We know mass is equals to density into volume. Density is 1.025. Volume is 120 meters into 15 meters into, this is light displacement, so we have to use the draft of light draft, that is 4 meter. When we solve it, we got the mass 7380 ton, that is 7380 tons. Now for load displacement, mass is equals to density into volume. Mass is equals to 1.025, that is density. Volume is 120 meter, 15 meter. Now draft we have to use, that is 9.8. So mass will be 18081 tons, that is 18,081 tons. So this is light displacement, this is load displacement. To find dead weight, that is short form DWT, what we have to do is we have to minus the light displacement from the load displacement, and consider this is second, this is first. So when you minus second from the first, we got the dead weight is 10701 ton, that is 10,701 ton. This is dead weight, 18,081 ton, load displacement 7,380 light displacement. So we have completed the question first. Let's do the question 2. Question 2 says that a box shaped vessel 100 meter long, 14 meter wide is floating in salt water at a draft of 7.6 meter. The light draft is 3.6 meter and load draft is 8.5 meter. Find the present displacement, dead weight aboard and dead weight available. Let's do the second one. What we have to find, displacement, that is present displacement, dead weight aboard and dead weight available. So first we have to find present displacement. That is mass is equals to density into volume. Mass is equals to density is 1.025 and volume is 100 into 14 into 7.6. So mass is 10,906 tons. Second we have to find the light displacement. That is mass is equals to density multiplied by volume. Mass is equals to density is 1.025, volume is 100 into 14 and draft is 3.6. So when we solve this equation, we got 5166, that is 5,166 ton. This is light displacement. Now we have to find load displacement. That is mass is equals to 1.025 multiplied by 100 into 14 into draft is 8.5. So mass is equals to 12,197.5 ton. Now we have to find the dead weight aboard and dead weight available. For that, we have to write their formulas. So present is 10906 ton, light is 5166 tons, and load is 12197.5 ton. To find dead weight aboard, we have to minus light displacement from the present displacement. Present minus light, that is 5740 tons. Now to find dead weight available, we have to minus present from the load. Load minus present displacement, that is 1291.5 tons. So we have find the present displacement, that is 10,906 ton. Dead weight aboard is 5,740 ton. Dead weight available is 1,291.5 ton. We have completed the second question. Now we will move forward. A ship is 200 meter long and 200 meter wide at the waterline. If the coefficient of fineness of waterplane is 0.8, find the TPC in salt water, in fresh water and dock water of relative density 1.015. Okay, so we have to find the TPC in salt water, fresh water and dock water and relative density 1.015. To find TPC, we use the one formula, that is TPC is equals to area by 100 multiplied by density of that water. Okay, to find area, what we have to do is area is equals to, we know that length into breadth into water plane coefficient. We use this formula because water plane coefficient is given here. So area will be 200 into 20 into 0.8, that is 3200 meter square. This is our area. So we will find the TPC in salt water first. So TPC salt water is area is 3200 divided by 100 and multiply by 1.025. This is area and density is 1.025 for salt water. So when you multiply 32 with the 1.025, you will get 32.8 ton centimeter inverse. This is the TPC in salt water. Now we have to find the TPC in fresh water and dock water, and our area is 3200 meter square. So TPC fresh water is equals to area by 100, or we can say that 3200 multiplied by 1, because the relative density of fresh water is 1. So when you multiply 32 by 1, it is 32.0 ton centimeter inverse. This is our TPC in the fresh water. Now TPC for dock water, that is 3200 divided by 100 multiplied by 1.015, and when you multiply, that is 20 into 10.5 into 1 into 0.82, 172.2, which is equals to 0.95, 163.59 tons. This is the mass that we have to find, and we found it. Fourth question is completed, guys. Let's do the fifth one, and this is the last question for today's video. A ship floating in salt water at a draft of 8 meter is 110 meter long and 14 meter wide at the water line. If the block coefficient is 0.72, find the displacement. If the load displacement is 12,000, find the dead weight available. Okay, so we have to find the dead weight available, and to find dead weight available, we have to find the dead weight available, and to find dead weight available, we have to minus load displacement. We have to minus present displacement from the load displacement. Load displacement we know the load displacement, that is 12,000 tons. We have to find present displacement. So what we will do, we know mass is equals to density into volume. Density is 1.025, volume is 110, 8 meter into 14 meter into, and because block coefficient is given, so we will multiply the 0.72 with the volume. So once we calculate these values. .025, that is density, and volume is 8,800,704. And when you multiply the volume with density, so our answer is 9092.16 tons. This is our answer. Now this is load displacement. This is present displacement. We have to find the dead weight available. So what we will do, we will minus the present, this is present displacement. We will minus the present displacement from the load displacement. Let's do it together. Present displacement is 9092.16 ton. So dead weight available is equals to 2907.84 tons. So guys, we have completed the question 5th also. Now only 5 questions are remaining there in the exercise 4. We will do these remaining 5 questions in the next video of this chapter, that is part 2, some important terms, exercise 4. तब तक के लिए देखते रहिए मेरा चैनल कपीश गौतम। मिलते हैं किसी नई वीडियो में किसी नए टॉपिक के साथ। तब तक के लिए जय हिंद, जय भारत, वंदे मातरम।